we've been talking a whole lot about the elements in the periodic table, right? We've learned about where the metals are located, where the nonmetals are located. We've learned the names of each of the groups. We've learned about these kind of middle elements called the metalloids that are like metals and kind of like nonmetals. And we've learned about where all the electrons are found in all of these atoms. But now what I want to talk about is how these elements or these atoms will react together with each other, because something that's interesting in nature is that majority of these elements do not exist by themselves in nature. Atoms rarely exist as independent particles. Nearly all of the substances in nature exist as a combination of atoms called compounds or molecules. What holds these combinations of atoms together? Well, you've probably heard the term chemical bond before, right? Chemical bond is not superglue. It's actually a mutual attraction between both atoms that keeps them close to each other. A chemical bond occurs when the nucleus of one atom is attracted to the valence electrons on the other atom. So let's look at the formation of salt. Okay, we know salt is made up of sodium and chlorine, right? And we also know in sodium that it has one outer valence electron because it's in group 1. And we know chlorine has 7 valence electrons because it's in group 17. And we know that these atoms are going to interact together very well because sodium is always going to want to lose this electron, and chlorine is always going to want to get 8, right? We call that the octet rule. The octet rule states that all atoms want to have a full outer energy level in order to be stable. Okay, this is why atoms form bonds, is so that they can have a full outer energy level. So sodium wants to have 0, and chlorine wants to have a full 8. So that's how chemical bonds are forming, is when the nucleus of one atom is having a strong pull on the electrons of another atom. It forces them to be joined together, and it's difficult for us to split bonds because this bond allows sodium and chlorine to be stable. Most elements, almost all elements, want to have 8 valence electrons to have theirs a stable amount, a stable number. Remember that 8 comes from having a filled s orbital and having a filled p, or having all 3 of the p orbitals filled, so that you get a total of 8 outside or 8 valence electrons, right? Now, there are a couple exceptions to that, being hydrogen and helium. They're happy or they're stable with 2 because all they ever fill up is the s orbital. They don't have a p orbital because the p orbitals are only found on the 2nd energy level, and we know hydrogen and helium only have enough electrons to be filling up the 1st energy level. Now, there are 3 types of bonds we're going to talk about. The first bond I want to talk about is the ionic bond. The ionic bond is formed between one element that's a metal and one element that's a nonmetal. So if we looked at our periodic table, we could predict which elements would form an ionic bond, right? Anything that's green on this periodic table is a metal, and anything that's pink is a nonmetal. So we know that anything over here could bond with almost anything over here, and what kind of bond would they form? They would form an ionic bond because an ionic bond is made up of one metal and one nonmetal. So if I looked at these 4 examples here and I asked you to tell me which ones were ionic, you would essentially have to look for which of these compounds has a nonmetal with a metal. So remember, if we're looking at our periodic table, that anything to the left of our zigzag line is a metal, and anything to the right of our zigzag line is a nonmetal. So here's my zigzag line. It always starts right at boron. It goes all the way down to right above polonium. So these are the nonmetals, and these are the metals, okay, on this side, and nonmetals on that side. So sodium, if I look, sodium is right here. It's a metal, okay, and then chlorine is a nonmetal. So this is ionic because it's a nonmetal and a metal. Now let's look at magnesium oxide. Here's magnesium, and here's oxygen. It's a metal and a nonmetal combined. Again, so it's ionic. These other 2 We'll find them only in the nonmetal section. For example, here's sulfur and fluorine. Okay, so these are not ionic. And then chlorine is a nonmetal, and so is hydrogen. Remember, hydrogen is the one exception that is not a metal. So since hydrogen is a nonmetal and chlorine is a nonmetal, then it's not ionic. Let's talk about the role of metals and nonmetals inside of an ionic bond. Okay, we know that the metals are groups 1, 2, and 13. Most of the group 13 is a metal, right? Because most of group 13 is to the left of the staircase line. So these are your metals, okay? And we know groups 1, 2, and 3 all give away electrons, right? Group 1 has a positive 1 charge, group 2 has a positive 2, and group 13 has a positive 3 charge because they give away electrons. Remember, anything with a positive charge we call a cation, right? And that T reminds us that it stands for the positive sign. So metals are going to form cations because they always have a positive charge. What does the positive charge stand for? Well, positive charge means that they're giving away electrons because they'd rather be at 0 than be complete at 8. So metals give or lose electrons. Nonmetals are the opposite. Nonmetals are mostly groups 14, 15, 16, and 17, and they have negative charges, right? Group 17 has negative 1 because it steals 1 electron. Group 16 has negative 2, and group 15 has negative 3. Since these have negative charges, it's because they're stealing electrons to get a full 8. The nonmetals are going to form the anion. So you should be able to look at an ionic compound right here and tell me what's the cation and what's the anion. The cation is the one that gives away electrons. The anion is the one that steals. Sodium is a metal, so it gives away its 1 electron, so it's the cation, meaning it's a positive charge. Chlorine steals electrons because it has a negative charge, and so it's the anion in the bond. In a bond, there's a complete transfer or stealing of the electrons. Let's use sodium and chlorine as an example. Sodium has 1 valence electron, right? Chlorine, on the other hand, has 7. It only needs 1 more, so it completely steals sodium's electron. Sodium no longer has it at all. So a complete transfer of electrons or stealing of electrons is what happens in an ionic bond because nonmetals steal and metals give away. This creates a charge for both elements. Sodium is now +1 because it gave it away. Chlorine is now -1 because it took it. Since each of these are now charged, we say that this compound is polar. We're going to talk more about this word later, but you'll need to know right now that polar means that something is charged. Okay, so if something has a charge, we say it is polar. Okay, so now let's talk about another type of bond. That's the covalent bond. A covalent bond is a bond between a nonmetal and another nonmetal. Of the Lewis dot structure of a covalent bond. Now, covalent bonds are a little different. Here's oxygen. And oxygen has 6 valence electrons, right? And here's carbon. Carbon has 4 valence electrons, and this is another oxygen with 6 valence electrons, okay? We know that carbon needs 4 more electrons, right? It wants to gain them. Oxygen wants to gain 2 more electrons, and oxygen wants to gain 2 more electrons, right? Okay, look what happens when they get together. Carbon is going to share 2 electrons from oxygen. That's why I drew these circles around them. And it's going to share 2 electrons from oxygen. So carbon, if we count 1, 2, 3, 4, 5, 6, 7, 8, has 8 valence electrons, but 4 of them are being shared, right? He's sharing 2 of them with this oxygen and 2 of them with this oxygen. And this oxygen is sharing 1 electron from carbon there and another electron from carbon here, so it has 1, 2, 3, 4, 5, 6, 7, 8 valence electrons. 2 of them are being shared. Now, the difference between an ionic bond and a covalent bond is that covalent bonds share electrons. You don't have one atom that completely stole the electrons from the other atom. Remember in ionic, chlorine completely took the electron from sodium, which made it charged? Well, here, carbon isn't actually taking any electrons away. They're being shared, okay? So these atoms are closer together because they're kind of all sharing their electrons so that they can get their full 8. So here's some important points about covalent bonds, is that nonmetals will share electrons. That forms the covalent molecule. And what helps me is the word co. Co reminds me of things like co-pilot or co-worker, and those are people that share the work or will share piloting the plane with you. So a covalent molecule is something that shares valence electrons. A pure covalent molecule, which is something that shares the electrons perfectly evenly, like carbon, oxygen, and the oxygen all are sharing the electrons the same way. Those do not have a charge like the ionic molecules did. So this sharing of the electrons is what holds the atoms together. And the last part is that since there's no charge to a covalent molecule, they do not conduct electricity well. The last bond I want to talk to y'all about is what's called a metallic bond. And there's really not a whole lot that we're going to learn about metallic bonds, except for that metallic bonds are formed between two metals. So on your notes that should say metallic bonds are formed between metals and metals. Okay, the atoms are kind of like all in a row, but the electrons are kind of spinning wherever they want in this compound. The electrons are able to flow in between all of the atoms. We say that the electrons are delocalized because metallic bonds form most of the time between transition metals. Remember how transition metals have electrons that are filling those d orbitals? And remember how the d orbital is like below the outer s orbital? Well, the s orbitals are all filled, like the 4s, the 5s, the 6s. So it's their electrons that are kind of underneath the valence electrons that are moving back and forth. And so we call this, whenever the overlapping d and outer s electrons form a sea of electrons, and that's what goes in your notes there, sea of electrons, where the electrons kind of move wherever they want to, okay? And this makes them have a high electrical conductivity, meaning they can conduct electricity insanely well because all the electrons are able to move, and that's what causes electric current. And so also because there's a lot of this movement going on, they're very malleable, metals are, and they're very ductile. Yay, chemistry, chemistry's fun. Yay, chemistry, we're not quite done. Yay, chemistry, so much fun. Keep on watching, it's gonna get better.